Hi folks, today I have a lesson for you about drawing alkanes. So to show you how the alkanes are drawn, I have some examples set up here and I'm going to go through those examples with you, explaining how we will go about drawing these common alkanes. So the first one I have is a simple alkane with no branches, no extensions, just a simple carbon compound. So let's say we have an example of butane. Butane, the first part of the word tells us, so I'm just going to switch to a pen, which is red here. The first part over here indicates how many carbons we have in this alkane. The word but means there will be 4 carbons. And the last part over here tells us about the family of the compound. So the first part told us it was 4 carbons, and the second part is talking about the family of the compound, which is an alkane family. Alkane, and alkane family would mean the bonds between the carbon and a carbon are all single bonds. So the bonds are going to be C-C. Okay, so now let's attempt to draw this compound butane. So as we have already established, there are 4 carbons. To start this off, I will draw one carbon, a bond, a single bond because it's an alkane, second carbon, third carbon, and then a fourth carbon. Once I have drawn all the 4 carbons with a single bond, I have no other information about any other components in this compound. So I will have to populate the carbons with hydrogens. Now, every carbon can have a maximum of 4 bonds. So one of the bonds, let's look at the first carbon here. The first carbon on the left has already utilized one of its bonding capabilities. So it has 3 more options or 3 more capacity remaining. So for those 3 points, we will put a hydrogen for each. And now this carbon has 4 bonds. Looking at the second carbon, it already has used 2 of its bonding capacity. So now it has only 2 more remaining, and we will draw those bonding capacities and place hydrogens on the top and the bottom. Third carbon, same idea. We have 2 capacities already consumed. We have 2 left, so we have 2 hydrogens attached to it. And the last carbon here has only 1 bond, so it has the capacity to form 3 more bonds. So we will add 3 hydrogens to this last carbon. So this carbon compound, butane, will have 4 carbons and 10 hydrogens attached to it. So if you're looking at the molecular formula of this compound, molecular formula for this compound would be C4 and H10. Another way of drawing the structural formula or writing the structural formula of this compound would be CH3, because the first carbon has 3 hydrogens, that's why CH3, and then the second carbon is linked to 2 hydrogens, so 2. The third carbon is linked to 2 hydrogens, so 2, and then the last carbon is linked to 3 hydrogens, and therefore a 3. All right, so that's a simple butane, simple alkane with 4 carbons attached. So we have a molecular formula and we also have a structural formula here. This one is called the condensed structural formula, whereas this one, the first one that we drew, was a complete structural formula, because this complete structural formula will show you all the bonds and the atoms attached to it, whereas the structural formula condenses the hydrogens with the carbon, so it does not show the carbon hydrogen link. All right, so that was butane. So that was the first one, simple alkane. So in the same way, you can draw pentane, hexane, or heptane, because the first part will indicate the number of carbons and the last part will tell us about the family of the compound, which is an alkane. The second one I have for you over here is when an alkane has a branch. So something is attached to our alkane, and a name for that one, so I'll move this up. A name for that one will appear to be like 2-methyl butane. So we still have a butane, but the part in the beginning, the prefix, is indicating that there is a methyl on the second position. So the ANE part is indicating what family this compound belongs to. The bute part is indicating that there are 4 carbons involved. The methyl is the name of a branch, and the 2 is the location of the branch. Okay, so we have a lot of information in this compound. So let's decipher this information and let's try to draw the compound. So again, like we did before, we have a butane. So we have 4 carbons. So I will draw the 4 carbons first, the backbone, 1, 2, 3, 4, with single bonds because this is an alkane family. And then I will look at the branch. So there is on the second carbon. So how do I label second? Well, I need to number my carbons. So I can start numbering from the left hand side or the right hand side. So this could be my carbon 1, 2, 3, 4. Okay, and this you don't have to really show it. This is for you to know when you're drawing the compound that you're starting from the left or you're starting to count from the right side. So in this case, I have chosen to start from the left side. Going back to the name is 2-methyl. So there's a methyl component on the second position. A methyl is a CH3 branch. So a branch which has a CH3. So on the second position, I will place the methyl again on the top or the bottom. That is all up to you. It's your choice. And I will place the methyl right there. So in this case, I have placed it on the second carbon on the top. And in the name, there are no other branches. So we have labeled and placed all the parts in the diagram. So now we have to just fill in everything with hydrogens. We just have to saturate the molecule with hydrogens. So first carbon has only one link. So we need 3 more. 1, 2, 3. So it will get 3 hydrogens. The second carbon has already consumed 3 of its bonding capabilities. It has already created 3 bonds. So we only have 1 bond capacity. So we will have 1 hydrogen. The third carbon has already utilized 2. So we will have 2 hydrogens on this one. And the fourth carbon has consumed 1 of its bonding capabilities. So it can have 3 more bonds, H, H, and H right there. So that is our structural formula. This is our complete structural formula. Looking at the molecular formula for this compound, we have 1, 2, 3, 4, and we have in total 5 carbons. So it would be C5 and H. How many hydrogens did we have? We had 3 plus 3, 6, 7, 8, 9, 10, 11, 12. 12 hydrogens, right? So we had 5 carbons and 12 hydrogens. And looking at the condensed structural formula, and I'm just using short forms here, condensed structural formula, it would be CH3, CH, because the second carbon has a hydrogen attached, and it had a CH3 attached to it. So in brackets, we will say CH3 to indicate that this is attached to the carbon. Then we have a CH2 and the last CH3. And that would be our condensed structural formula for 2-methylbutane. Right, so that was our second one. Let's go for the next. In this case, I have for you a 3-ethyl 2-methylpentane. So this is an alkane which has 2 different branches on the same molecule. So same idea. Last part of the name tells us about the family. The pent tells us that there are 5 carbons. The other 2 pieces tells us about the branch. We have a methyl branch on the second position, so it's a branch. And the third position, we have an ethyl branch. Right? And if you want, we can write it down. Ethyl branch is a CH2, CH3. eth means 2 carbons, so it's a 2 carbon branch, and a methyl is a 3 carbon branch. Sorry, it's a 1 carbon branch because meth means 1, so methyl is 1 carbon branch, CH3. Right, so now we have all the pieces of the puzzle. It's a 5 carbon chain which has a methyl branch on the second position and an ethyl branch on the third position, and then we will just populate everything with hydrogens. So first, initially, 5 carbon chain, 1, 2, 3, 4, 5 carbons. On the second carbon, I'm going to put a methyl group, so position 2, CH3, and as I said, you can start from the left or the right, but once you choose a direction, you stick to that direction. In this molecule, I have started to count from the left, so on the second position, second carbon, I have a methyl, and on the third carbon, I'm going to place an ethyl right here. So I have placed methyl on the second position, ethyl on the third position, and all the branches are filled in the molecule. They are already drawn. Now I have to fill hydrogens. So recall from the previous example, every carbon has a bonding capacity of 4. So it needs to form 4 bonds. The first carbon has already consumed one of its bonding capacities, already has 1 bond, needs to have 3 more. So 3 hydrogens here. The second one has consumed 3 of its bonding capacity, so 1 more here. The third one has also consumed 3, so 1 more hydrogen here. The fourth one only has 2 bonds, so 2 more to go. And the last one only has 1 bond, so we have to add 3 more hydrogens. Right, so now we have all the entire structure drawn. We have a complete structural diagram. The molecular formula for this compound would be number of carbons that we have in this. We have 5 plus 1, 6 plus 2, 8 carbons. So we have C8. So we have 8 carbons, and then number of hydrogens, we will have number of hydrogens, 18 hydrogens, and you can check that we have 3 plus 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 hydrogens. So we have 18 hydrogens there. Drawing it or writing it down in a condensed form, it becomes a little more complex, but we can still do that. We have a CH3. The first carbon has 3 hydrogens. Second is CH bracket CH3. And then the third carbon is a CH bracket CH2 CH3. And then the fourth one we have is CH2. And then the last one we have is the CH3. Right, so we have a condensed structural formula as well. Okay, so we have an alkane with 2 different branches now. Alkane with the same branches, that can be also drawn as well. Same idea. So in this case again, pentane, 5 carbon chain. So we have pent, 5 carbons. ANE is telling us about the single bonds. So that's a family. Carbon, carbon single bond. And methyl, so it talks about the branch, which is this is the branch. And it says dimethyl. The di part is not the name of the branch, it is indicating that we have 2 of these branches. So we have 2 branches of methyl. So since we have 2 branches, we have to indicate, or the name will tell us where each of the branch is. Even if it's on the same spot, we have to show, or the name will tell us that it's on the same location. So in this case it says 2, 2. That means both the methyl branches are on the same second position. So let's draw our molecule here. 5 carbon branch, 5 carbon backbone, 1, 2, 3, 4, 5. On the second carbon, I'm going to place a methyl CH3, and I have another methyl, so that would be on CH3. So I have to place both of them on the second carbon, so one above and one below. I cannot put the CH3 on top and the second CH3 on top of that, because that methyl branch has to be connected to our second carbon. Okay, so we have the branches attached now, we have the backbone, the main chain, and now we have to just fill in hydrogens in the structural diagram. So the first carbon has only one link. I'm going to add 3 more. 1, 2, 3. The second one already has 4 links, so I cannot add any more. The third one, I have to add 2 more. The fourth one, I can add 2 more here. And the fifth one, I can add 1, 2, 3. So now I have the complete structural diagram for 2,2-dimethylpentane. Right? And the molecular formula, MF, for this one would be, again, carbons. I have 1, 2, 3, 4, 5, 6, 7 carbons. So the number of hydrogens I will have is 16. Okay, so I have 7 carbons and 16 hydrogens. Right. And for this one, when we're writing the condensed structural formula, CSF, so it will be carbon, and the first carbon has 3 bonds or 3 hydrogens attached. The second carbon has CH3, 2 of them attached onto the carbon, and then the next carbon has 2 hydrogens. The next carbon has 2 hydrogens, and the last carbon has 3 hydrogens attached to it. Right, so that is an example of an alkane with 2 same branches and how we would write the structural formula and the molecular formula for it. Right, next one I have for you is a ring configuration or a ring form or a cyclical form. So in the cyclical form, the first carbon and the last carbon are joined together or they are linked together. For a cycloalkane, the minimum number of carbons we need to have is 3 carbons. A cycloalkane cannot be built with less than 3 carbons, and can be built with anything with more than 3 carbons, but nothing less than 3. In this case, we have a cyclopentane. So the word cyclo, the prefix cyclo, indicates that it is a cyclical or ring form. So it's a ring compound. The pent component tells us that there are 5 carbons, and the ane is the family of alkanes, which means it's carbon-carbon single bonds. So they're all carbon-carbon single bond linkages. Now, once we have deciphered what this name is telling us, we can start to draw this compound. So in this case, we have to draw 5 carbons in a ring form. So 1, 2, 3, 4, 5. And if you see now, I have 5 carbons and they're in the ring configuration. The first and the last carbons are linked together. There are no other branches, so we don't have to add any branches to this ring structure, and we just have to fill the hydrogens. Now, each carbon, so let's start taking with this first carbon here, or any carbon, could be number 1, already has 2 links, needs to have 2 more. So 2 hydrogens here, 2 hydrogens there, 2 hydrogens there, 2 hydrogens here, and 2 hydrogens there. All right, so we have our ring structure here, and for this one, I'm only going to give you the molecular formula. We have 5 carbons, so it would be C5, and number of hydrogens would be 10, the double of 5, because every carbon had 2 hydrogens linked to it. So it would be 10 hydrogens. So we have it right there. That is our cyclopentane. There is another way of drawing it. So since I'm not showing you the condensed structural formula for this, I will show you the line structural diagram. So there is something called the line structural diagram that you can show for this molecule, and this one will show a diagram where every vertex represents the carbon and hydrogens are not shown. So for cyclopentane, it would be 1, 2, 3, 4, 5. There we go. So we have 1, 2, 3, 4, 5 carbons right there. So those are the 5 carbons. That would be a pentagon. A pentagon is a cyclopentane. Right. So the structural diagram of cyclopentane looks like a pentagon. Right. So that was cyclopentane. Now, a cyclical compound can also have branches. So I'm going to show you an example of methyl propane, uh, which will be a cyclic. It would be methyl cyclopropane, and the prefix cyclo is very important to indicate that it is a cyclical compound. So I have a methyl cyclopropane, and in this case the methyl component is the branch, and this is prop, which means it's a 3 carbon compound. Ane is carbon carbon single bond, and this is telling us it's a ring structure. Right, so we have deciphered all the information that is given in the name. So let's now try to draw. So 3 carbons, 1, 2, and 3, and that's linked together. So that's a cyclical compound, cyclopropane. So first we have drawn the cyclopropane. Now we will add a branch. Methyl is the branch name, which is a CH3. Now we can put this CH3 on any of the 3 carbons. It is the same either way. So once we have placed our methyl on any one of the carbons, that carbon automatically becomes carbon number 1, because that's the only branch in the molecule. So this carbon here, let me switch the pen so that you can see, this carbon here is carbon number 1. Right, this can be number 2, this could be number 3, but number 1 is fixed. This is fixed. Okay. So now I will draw the remaining hydrogens. So we have hydrogen. On the first carbon, we already have 3 linkages, so 4th linkage here. For the second carbon, I have 2 linkages, so 2 more linkages here. And the third carbon has 2 linkages, so I'm going to show 2 more linkages here. Okay, so I have the 4 linkages for each carbon, and I have completed the structure of methyl cyclopropane. Also, another way of drawing this methyl cyclopropane would be right here, so I can show you the line structural diagram. For this one, it's going to be a triangle because 3 carbons is a cyclopropane, and we'll have a methyl attached to it, so a branch attached to it. So that's a methyl cyclopropane. And if you are looking for the molecular formula, since we have been working on molecular formulas, we have in this case 4 carbons, so C4, and we have 4, 5, 6, 7, 8 hydrogens, H8, which is double the number of carbons. So cyclical compounds has number of hydrogens equal to double the number of carbons we had. So general formula of CnH2n. So double the number of carbons is the number of hydrogens. Okay, so that was a cycloalkane with 1 branch. And the last one I have for you, oh sorry, it's not the last, second last that I have for you is cycloalkane with 2 branches. So in this case, we have 2,2-dimethyl, again a cyclopentane. I'm going to change that name right there, cyclopentane. That is very important for a cyclical compound. So 2,2-dimethyl cyclopentane. Let's draw this out and see what information we have. It's an alkane family. And pent represents 5 carbons. Cyclo means it's a ring structure, a ring diagram. Methyl is the name of a branch. which is a CH3. Di means we have two of them, so times 2, and the location is 2 and 2, so that's the location on which carbon these branches are located. So once we have deciphered all the components of the name, let's start with the longest chain, which is 1, 2, oh, it's a ring structure, sorry. Let's draw the ring structure first. 1, 2, 3, 4, 5. So we have a 5 carbon ring, cyclopentane. So we have a cyclopentane on position 2. So it says 2,2-dimethyl. So you have to draw the diagram. You have to number the carbons. Let's say this is 1, 2, 3, 4, 5. Right, so now we have 5 carbons. So it says carbon 2 has the methyl groups, so CH3 and CH3. So I'm numbering that as carbon 2 and I'm putting the methyls on that carbon. And once I have that, then I can fill remaining carbons with hydrogens. So if a carbon has only 2 links, we need to add 2 more, like in the case of first carbon here. The second carbon already has 4 links. Third carbon has only 2, so I have to add 2 more. Fourth carbon has 2 links, so I need to add 2 more. And the fifth one has 2 links, and then I have to add 2 more. A simple line structural diagram for this would look like that, with 2 branches sticking out for methyl on it. Now, this compound that we have, this name 2,2-dimethyl cyclopentane, would not exist because the location where the branches are, that is where you will start counting the numbers. So technically speaking, the name for this compound should have been 1,1. So it's a correction at the bottom. I will put a correction here. Correction. The name of this compound should have been 1,1-dimethyl cyclopentane. So it would be 1,1-dimethyl cyclopentane because the methyls are attached to the first position. All right, and then the molecular formula would be exactly the same way like we have been doing the remaining ones. The molecular formula would be, we have 5 plus 2, 7 carbons, so C7 and H14. So 7 carbons and 14 hydrogens. Perfect. And the last one that I have for you is cycloalkane with 2 different branches. And again, since we looked at the correction in the previous one, I'm going to change these numbers beforehand. These numbers, I will change them to 1 and 2 so that my name would be correct. Okay, so I have cyclopentane. Deciphering this name, it's a carbon single bond alkane family, and we have pent, which is 5 carbons. And again, there's another correction. This is not a cyclo compound yet, so I will have to have the word cyclo as a prefix. Cyclopentane, which will tell us there is a ring structure, ring. And then on the second position, we have a methyl, CH3. And the first position, we have an ethyl, which is a CH2, CH3. So we have all the components to draw the structural diagram. So starting with the first one, cyclopentane. 1, 2, 3, 4, 5. So we have 5 carbons here. And so we have a cyclopentane on the second carbon. So we have to label our carbons, and again in the beginning you can start from anywhere you want. 1, 2, 3, 4, 5. And Now I can put a methyl on the second carbon. So this one now is the second carbon, CH3, and an ethyl on the first carbon, which is a CH2, CH3. So we have now ethyl on the first position, methyl on the second position in a cyclopropane. Now we have to saturate the molecule with hydrogens so that every carbon has 4 linkages. Carbon 1 has 3 linkages, so I'm going to add another one, which is a hydrogen. Carbon 2 has 3 linkages, add another one. Carbon 3 has 2 linkages, so add 2 more. Carbon 4 has 2 linkages, add 2 more. And carbon 5 has 2 linkages, so carbon 5 has 2 linkages, so add 2 more. So now we have the diagram. Now, the complete structural diagram looks very messy, lots of components in there, and that is why we like to draw the line structural diagram. So for the line structural diagram, we would have, have 1, 2, 3, 4, 5. Okay, so we have our cyclopentane, and on the first carbon, we will put a CH2, CH3. And this is a partial line structural diagram. And we have a CH3 here. And this looks much more clean compared to the first diagram, giving us the same information about 1 ethyl, 2 methyl cyclopentane. And again, molecular formula would be, we have in this case 5 plus 2, 7 plus 1, 8 carbons. So C8, H would be double of that, so 16 hydrogens. So C8H16. I hope you enjoyed this lesson and were able to learn something about alkanes. I hope you have a great day and enjoy this lesson. And if you liked it, please subscribe. And if you have comments, please feel free to post at the bottom. Everyone, have a great day.